Hello, this is Michael Oliver, and this is Module 2 for Multiple Regression. Alright, so for my first piece of my module, I wanted to look at the moderation. In order to look at that, it's best if we start to look at the equation before anything else. From here, we can see what the b's mean for further interpretation. So the equation can be formatted in two ways, as you can see, just arranging it in different order. B naught is simply the intercept of the non-treatment or the base group, or whatever group happens to be at the start. And I'll explain that later on. B1 is the slope of that same group, and then B2 and B3 are the intercept and the slope of the treatment group and how they are changed, how they are different from that treatment group, from the non-treatment group that we used from the first B0 and B1. So for our first moderation, I wanted to look at the effect of different types of ice cream, specifically banana and cookies and cream flavored ice cream, on happiness. So I tested the full moderation model. We see that the estimates are B naught is 0.09, negative 0.09, B1 is 0.02, B2 or B3 is 13.06, and B3 is negative 3. While B2 and B3 are the only ones that are significant. What all this means is that there is no slope and no intercept significantly different from 0 in our non-treatment group, which is banana, and the slope and the intercept both were significantly different from the non-treatment group. So cookies and cream, which is our treatment group, was significantly different in both slope and in the intercept. You can see the equation for the specific model on the bottom left. And we can also see a further analysis of here. So we see that B0 and B1 are non-significant, as you can see in the bottom right. B2 and B3 are significant. The model as a whole signifies that while banana ice cream does not change your happiness level at all, it remains 0 throughout. Cookies and cream ice cream does increase your happiness at the start because of the increased intercept, but it decreases your happiness over time compared to banana. Alright, and quick look at the diagnostic. Everything looks to be pure normal distribution of residuals, no clear leverage. The expected residuals are around 0, so everything makes sense for the diagnostic purposes. For the next moderation, we have the effect of reading and happiness, or reading and statistics on happiness. So we see that in this one, the estimate for B0 is 0.02. The estimate for B1 is 0.02. The estimate for B2 is 2.01. Estimate for B3 is 0.00. The standard error are all very, very small because I created the for all of these, the standard error will be very small because I created this data set with small variance. As you can see from the data points in the line, they're all pretty focused around that line of best fit. And we can also see that the only thing that changes is the intercept between the two different treatment groups. It changes from 0 to 2. Also, all of the R squares in these moderations have the last one at 0.93, this is 0.96, all high adjusted R squares, showing that the equation in the model that we use greatly predicts our dependent variable. You can also see the equation on the bottom left, but it's also explained here. So we see that the only significant B value that we have is B2, meaning that the only significance in our moderation is the intercept from one to the other. Effectively, statistics and reading both do not increase your happiness over time, but reading does start at a higher happiness level to begin with compared to doing statistics. Obviously, no one's happy doing statistics. The diagnostics for these are just about what we would expect to see as well. No clear leverage, same thing. Residuals around 0 for the mean residuals. Everything seems to make sense. For the last module we have shoes versus non-shoes and the effect of happiness while running. So it's time spent running, and we see that for no shoes, your happiness starts at 10, so it has an intercept of 10, and this is the non-treatment group, and you have a negative value, a negative 1.6, as we can see from our B2 value for the X estimate. So we decrease happiness, so for every every unit of time spent running, our level of happiness goes down by 1.6. And this is a continuous level of happiness just because. It also starts at a solid 10. Don't know what the max is, but it starts at a solid 10. We can also see that for the treatment group, for the shoes treatment group, while the slope does not change, it is not significant. The only change that is there is the intercept. So instead of starting at 10 happiness, you start at 16 happiness. Also for the R-squared, we have 0.98 again because I created the data with low variance. What this means essentially is that unhappy people, people get more or the same amount of unhappiness over time, but people are starting out slightly more unhappy from running with no shoes as compared to the people with shoes. Or rather, the people with shoes get unhappy at the same rate, but start out higher, either way to put it. And you can see on the graph that the slopes are exactly the same, the only difference being the intercepts. All right. And finally, just a diagnostics, same thing as before. The diagnostic graphs all appear to be what we would expect and no clear problems. All right, so next we're looking at the mediation. For my first mediation model, I wanted to look at the mediation effect of the relationship between burgers or eating burgers and the satisfaction with a mediation variable of sushi. So I want to look at how sushi, burgers, and satisfaction all relate to each other using satisfaction as the dependent variable. First method we're going to use is the checklist method, as shown in the Barron and Kenny 1986 article and everywhere else that they try to put it. So the checklist method is simply going off through each of the stages and doing a regression analysis on each part, and if it's significant, then moving on to the next one. So for the first one, as you can see, is doing the checklist on the C relationship. That is, if burgers can predict satisfaction. We see that it can with a b-value of 2.97. These are all b's and not betas, so nothing is standardized because burgers and sushi might be on a different scale, and I wanted to relate each one of those scales not to each other, but to themselves, and I don't want to standardize and lose variance, so everything's a b. We see that it is significant at a very significant level. So we move on to the A relationship. So can burgers accurately predict or effectively predict sushi? We see that that is also significant. The b-value is 1.02. So every one burger, you can increase one sushi. Makes sense. And it is also significant at a very high level. So next you look at the B relationship. That is also significant. That is looking at if sushi can predict satisfaction. That is significant at a very significant level, and the b-value is 2.8. So for every sushi you eat, every piece of sushi you eat, your satisfaction goes up by almost 3 points, which makes sense to me. Sushi and that's very similar to burgers, which is a b-value of 2.97, which makes sense. Eating burgers and sushi both make me very satisfied. And then after that, you were in the checklist method, you'd also test C prime to see if the relationship between burgers and satisfaction is still significant after you test the relationship between sushi and satisfaction. We see that it is significant, the relationship between burgers and satisfaction. Instead of a b-value of 2.97, we get a b-value of about 0.5. It is less significant. We see that the error rates throughout are all pretty small, the main difference being the estimates. So we see that it is still significant, but just. Next, we use the Sobel bootstrap method, slightly different, using testing all of the things in one model instead of individually at each time. So we see the indirect, which is the ACME, the indirect effect, and the ADE, which is the direct effect. That is similar to here, the direct effect being burgers to satisfaction, and the indirect effect being burgers to sushi to satisfaction. So we see here that the indirect effect over here is significant at a 0.04 p-value, so it is just less than 0.05, and the direct effect is also significant. We also see that the total effect is also significant. So this is just another way of showing that our entire model is significant. Burgers can predict satisfaction. We have enough evidence to suggest that burgers and sushi both can predict satisfaction, and burgers can predict sushi. So the full mediation model is significant. You can also see in the graph on the lower left, because the dots represent the estimates, the lines represent the lower and upper confidence intervals, and they're all significantly away from 0 because 0 is not even on the graph. For this, I used bootstrapping, so running this equation 1,000 times, and we get these. That's where these estimates and confidence intervals come from. A quick look at the diagnostics here. Things are a little bit messed up. We see that there's, on the top left, we see that there's no clear leverage, but we see on both the bottom left and the top right, we see that there could be some issues at the tail ends of our data set, as well as that QQ norm plot. We see that the top right tail tends to skew off a little bit, but that is what it is, and I won't expect it to affect too much. All right, next we're looking at the second mediation model we have. This is using that same checklist from Barron and Cuddy. So we want to look at if Nick Cage can predict money, and if work can be a mediating variable between those two things. So if Nick Cage can predict work, and work can also predict money, to see if the entire relationship is significant. And going back to the same method, we first test Nick Cage to money. That is an estimate of 1.01, and it is very significant. So we move on to a relationship between Nick Cage and work. That is also a significant estimate around 1. So we see that Nick Cage can predict money, and Nick Cage can predict the amount of work. So next we would look at if work can predict money. That is also rather significant, slightly less of an estimate of 0.73, but all of the standard error is about the same, meaning that the variance is really small between all of these variables, but work is slightly less predictive for money. Finally, we look at that C prime relationship, which is the relationship between Nick Cage and money after we take into account the work effect. We see that it is not significant in this method. So we see that when we account for Nick Cage, in fact, we lose the relationship between work and money. So we see that we do not have enough evidence to suggest in this method that work can be a mediating variable on money, and it is simply a relationship on Nick Cage to work that could show up as a false mediating variable. So the only actual statistically significant relationship would be that of Nick Cage and how he relates to money. So we see that the estimate of work to money drastically goes down from 0.73 to negative 0.08 with a p-value of 0.42, very insignificant. So finally, we can see that from our other method shown from Kenny in 2018, he talks about the bootstrapping method and the Sobel method and whatnot. We can see that while there is a direct effect using this method, there is no indirect effect. So we can also see that in the graph. So the ACME, the one on top, is not significantly different from 0. The confidence intervals do interact with the 0 estimate, and we see that while the estimate is negative 0.1, it has a p-value of 0.63, so it's not really close to being significant. While we do see that our direct effect, the ADE, or the relationship of Nick Cage directly to money, is still significant in this method. We do see the total effect, but that is mostly due to the Nick Cage effect. Again, looking at the bootstrapping method with 1,000 simulations, normally it's good to use the two different methods because they could produce two different results. In this instance, they do produce the same results, but as Preacher talks in his 2008 article, the results from the checklist method could be different, and it is good to keep an eye on both. So finally, we see for our final model that it means that there's evidence to suggest that Nick Cage can predict money, as we would all know, but work is not supported by enough evidence as a predictor of money, which makes sense to me. You can watch as much Nick Cage as you want and get a whole bunch of money, but sometimes you can work for hours and get no money. So it makes sense. Looking at the final diagnostics, we see pretty much exactly what we would expect. No major variations from what we would assume. The residuals have a mean of normal, and the residuals, none of the observations have any large amount of leverage. these things are important to look at, as Kenny talks about in the 2018 work. And that is the final module.